This is part 2 of lesson Intro to Limits 11.1. In this lesson, we're going to mostly be looking at the graphing side of things and how to find limits using the graph. In this case, we've got the graph of x plus 3, and we're looking at the limit as x goes to 4. So count 1, 2, 3, 4. Here's 4, and we're looking right here, right? From the left side, less than that value, what is the y value that this graph is approaching? So 1, 2, 3, 4, 5, 6, 7. So that is y is 7. And at x is 4, this graph is approaching y is 7 from the left. From the right, is it also approaching the same spot? Yep, it is linear. It is also approaching the same point right here, which is 7. And so, in this case, the limit of the graph is 7, right? Because both sides matched. Next one, we've got limit of this x cubed minus x squared plus x minus 1 all over x minus 1 as x goes to 1. Okay, so x is 1 right here. And what is the y value? 1, 2. So right here, the y value is 2. And from the left side, we are approaching y is 2 in this graph. Now, y cannot equal 2 at this point, because at 1, you'll notice 1 minus 1 would give us a divide by 0. But that doesn't matter. As long as both the left side and the right side match which point they're approaching, the limit will still exist and be that value. On the right side of 1, right? So from this greater side, we're looking this side, right? So now I'm looking at like 1.9, 1.5, 1.1 for my x values. We're approaching the same y value, right? It's approaching the same hole right at y is 2. So since both sides match, right? This side's going to 2, that side's going to 2. Since both those match, the limit is 2. Next, we've got the limit as x goes to 0 of x plus 1 over x. Now, in this case, right, we're approaching 0, right? So from the left side, the graph is going straight down. It looks like it'd be like minus infinity. Now, that's not a value, right? That's a concept. So minus infinity. But on the right side, right, over here at like half to 0.1, we're approaching the other side. It almost looks like it's going straight up, right? That looks like the positive. Those don't match. So in this case, we've got a classic case of DNE, which again stands for does not exist. It's just quicker than writing with my handwriting, sorry, but does not exist. Again, doesn't exist because the left side and the right side did not match. Next, on to 13. And yes, the numbers are a little goofy on this lesson. We've got f of x is 3x plus 1 for x greater than or equal to 3, and f of x equals 2x minus 3 for x less than 3, right? This is a piecewise function. Notice less than 3, that would be an open. This side's open. Greater than or equal to 3 would be filled in. That's this side. So on the left side of this graph, what value are we approaching, right? So 1, 2, 3, right? At limit as x goes to 3, by the way. Sorry. Look at that. Here's the problem. Limit as x goes to 3 of f of x. So 1, 2, 3. We've got 1, 2, 3 is our y value here. Continuing to count, 4, 5, 6, 7, 8, 9, 10. Limit is 10, sorry. The value is 10 up here. So on this side, from the less than side, we're approaching x is 3. So again, left side, we're approaching 3. Oops. From the right side, right, now we're up here at 10. This purple line looks to be approaching 10. Right now, technically, if you plugged in 3 times 3 plus 1, that would make sense, right? That graph makes sense. That right side, the graph is approaching 10. Real easy question. Does 3 equal 10? No, right? When they are not equal, right? When we've got a not equal sign, that means the limit does not exist again, right? So those aren't the same. Limit does not exist. Same meaning as last slide, does not exist. Moving on. Now this time it is still piecewise, but if you look at the graph, They meet at the same spot. So checking it out here. We've got the limit of f of x as x goes to 4 of this function. Again, not too worried about it. It's accurately graphed here. And so from the left side, in purple this time, we're approaching this value, which is 1, 2, 3, 4, 5. Right? Y equals 5. So from the left side, I've got 5. Now from the right side, what do we have here? It looks to be the exact same point, right? That is also 1, 2, 3, 4, 5. So on the right side, we are also approaching 5. And so since those are equal, the limit does exist, and it's that number. So the limit is going to equal 5. Right? Again, because these match, it equals 5. I think we got those numbers from looking at our y values from the left side of the x and from the right side of that given x value here. Now, here is an example that looks a little off, okay? So just as a reminder, we're going to go back to that intro slide, right? This is actually going to be case number 3. Now, this is why I didn't draw an example, because it is quite a messy looking one. So let's get back there here. Now, this is what they mean by oscillates in this case, okay? It looks like a big blob. Not to use too fancy of a math term there, but it does. It looks like a blob. And I'm like, wait, does this graph actually look like this? Go ahead. Feel free to graph it on your TI. It is a little bit of a mess. Now, what they're doing is, okay, we're going to look for the limit as x goes to 0 of cosine of 1 over x. Okay. Now, we know cosine of like our zeros or pi's. Well, we can't make this equal to 0, but to make it equal to pi, I could plug in 1 over pi, because then I'm going to have cosine of 1 over pi multiplied by pi on top and bottom, and this is equal to cosine of pi, which is -1. So in that case, all right, we've got -1 is our number for the first one. Okay. Now, what about 1 over 2 pi, right? Cosine of 2 pi is +1, right? 1 over 2 pi is going to have the same pattern, but then cosine of pi is 1. And notice, what is 1 over pi? 1 over 3.14 is like 0.3. 1 over 2 times pi, 1 over 6.28, it's going to be like 0.16. So we're getting smaller. We get even smaller and it bounces back. 1 over 3 pi plugged in gives you cosine of 3 pi, right? And it's just going to keep doing this ping pong back and forth, right? And these, again, these numbers are getting smaller and smaller, and it can't even settle. And this is only one side. So since one side not even settling at which value it's going to approach, we're going to say the limit as x goes to 0 does not exist, because it won't even have a limit on just one side. We couldn't look at both. Just one side didn't give us an answer. Now, moving to real basic plugins, okay? Basic limits, again, are when, again, just given the situation, limit is x, limit of b as x goes to c, right? So for those who are like, wait, what? This is the same as saying, what's a limit of 8 as x goes to 3? Well, there's no x in the equation, so 3 is still 3. Or 8, sorry, limit of 8 as x goes to 3. It's still 8, so this is an example. Limit of 8 as x goes to 1. Well, there's no x, so that it's just going to equal 8, right? And again, little note, n's positive integer, b and c are just real numbers. So the limit of x as x goes to c is c, right? We basically can just plug c in. Now what about limit of x goes to c of x to the n, right? Same idea. We could plug c in there and we get c to the n. And what about if it's a square root? And again, this is a note that it has to be for even, so we're not dealing with negative square roots. Makes sense. Also, we're not dealing with cube roots and things like that, right? So that's why there's no negative under the square root, right? So limit as x goes to c of the nth root of x equals the nth root of c. Okay. Other properties of limits. Now here's some rules we can follow. Let b and c be real numbers, n's a positive integer. F and g are functions such that the limit of f of x as x goes to c is L, and the limit of g of x as x goes to c is K. We can do scalar multiplying. Well, this limit is L. What if we multiply it by b? B times f of x would give us b times L as our answer. Okay. Sum or difference. What if we added the limits together, right? We're going to get L plus K, right? As x goes to c of f of x plus g of x, we can add them or we can subtract, right? Plus or minus means plus we would add them, minus we would subtract them. If we multiply, we can multiply them. That's the next part, product. Quotient is divide, right? F of x over g of x, with the little note that k cannot equal 0, right? It is possible for a limit to go to 0, but we can't divide by 0. Power, limit of f of x as x goes to c to the nth power, f of x to the n will be L to the n, right? Pretty straightforward. And so we're going to do some of these. So starting off, limit of x cubed as x goes to 4. Well, that's going to be 4 cubed, which is 64. Pretty straightforward. The limit of 7 as x goes to 10. I don't see an x, so the limit is going to be 7, right? It's a constant. Limit of x squared minus 4x plus 8 as x goes to 3. You could try some of these on your own by pausing the video and testing out if you got it right. Now that we're back, right, we've got the left side equals 5, the right side is minus 21/6. Again, plugging it in, giving you time to write here. 3 squared minus 4 times 3 plus 8. 9 minus 12 is negative 3 plus 8 is 5. 2 squared plus 5 times 2. I got 4 plus 10 is 14. Minus 35 is negative 21. 2 plus 4 is 6. Negative 21 over 6 can be simplified to negative 7/2. If you wrote negative 3 1/2, that is also fine. And then there is the homework.